In this lesson, we're going to be talking about format string attacks. So I've got this program here that's vulnerable to a format string attack. And again, this is written in C. And I'm going to walk you through the program here. Again, at the top, we've got 3 include lines where we're including definitions from libraries that are external to this particular program. So I've got the standard IO and I've got the string library. And then I've got just the standard library. And the standard library has functions that don't really belong in any other specialized library. It's just a collection of a bunch of miscellaneous functions that are part of the C standard. And so it's the C standard library. So we've included that as well. We've got the main definition for the function. And then I've got a variable underneath that I'm calling x, and x is a pointer. And I'm not going to get into a lot of detail about pointers, but a pointer is a variable that's actually an address, and it points to a chunk of memory. And since I'm doing a dynamic allocation with malloc, it's going to point to a place in the heap. So this variable with the address is stored locally in the stack frame, but the address that it points to is actually in the heap. And I'm doing a string copy here, and then I'm just calling printf. Now, normally I would call printf with something like this. And I would have my format string, which is the %s, which tells printf, this is the format that I'm printing out in. I've got a string that I want to print, and then X is that string, and that's where I want to put it. But what I've done here is I've just done printf without any format string, and so that's where I become vulnerable to a format string attack, because I haven't provided the format string as a programmer, and so I open the door to an attacker actually creating a format string and passing it into my program. So what I'm going to do is pass a variable in as an argument, and in this case I'm looking for a hexadecimal value. So I didn't print out the %x, even though that's what you would think would be printed out here because of the way the program is. I've got the printf, and in parentheses I've got x, which is the variable. So I'm printing the variable x, and normally you would expect that %x would be my variable, except that I didn't provide a format string in printf. So printf took that first piece and assumed it was the format string. And so it took the %x and said, you're looking for a hexadecimal value, and then it grabbed the next thing off the stack. Since that's what it's programmed to do, that's how a function call works. It just starts grabbing values off the stack. So that's what printf did, is it grabbed the next value off the stack, which could be anything. And you could do this a couple of times and see whether you get different values. So I could put quotes here around this, turn it into a format string, and in this case, I get that value and I get a 0 for my second one. So this is how a format string works, though, where a programmer is calling a function that requires a format string and they don't actually provide the format string. That allows an attacker to provide the format string, and because of the way stacks work, it has the possibility of grabbing data right off of the stack. And that data isn't part of the function that has been supplied by the user. It's some other piece of data. Now, with format string attacks, you can do things like getting return pointers if you can dig deep enough into the stack. You can also use a particular format, which is %n, sometimes in order to inject code into the stack or inject data into the stack. And that's something that you may be able to do as well. So in general, though, this is a format string. This is the basics of a format string attack and what a program that was vulnerable to a format string attack would look like.